This video is added on to our two-body problem questions, and this is just a couple other examples for you to look at and to understand. Here's a typical problem you would see in physics with you have two masses attached with a pulley and the same string. So the tension's the same in both strings wherever we're at, right? So what happens is when we release this block 2 moves that way, block 1 moves that way as it accelerates down. Table's frictionless, so we're about friction. We also assume the string is massless and the pulley has no mass or friction. So we're making a lot of assumptions here that aren't real. But the math will help you solve other problems. So what we want to do is we want to find how fast they accelerate and the tension in the string. Now they share the same string, so the tension in one will be the same as tension in the other, and also they'll have the same acceleration because they're attached. So like all of our two-body problems, we break it up into different free body diagrams. So M1 has gravity and normal force with a tension force that's pulling it along. Gravity, mass times g, so 5 times 9.8 or 49 newtons. That's exactly what our normal force is. And now the force of tension is our unbalanced force, so that's our net force. So our net force is equal to ma, with the mass of this being 5. So tension, the force of tension is 5 times acceleration. Now we draw the free body diagram for our second mass. And this one's different since it's suspended from the string. We got gravity going down and we got tension going up. Now this object is moving downward, so it's accelerating downward. So in this case we make gravity positive, tension negative, okay? And you'll see why when we do the math. But our net force then is going to be gravity minus tension equals mass times acceleration. Force of gravity is going to be mass times g, so 8.5 times 9.8, which is 83.3 newtons. And we want to solve for tension. So Fg is 83.3 minus Ft, which we said is 5a. That equals the mass of block 2, which is 8.5 times a. Add 5a to each side. 83.3 is equal to 13.5a. Divide both sides by 13.5. A is going to be equal to 6.17 meters per second squared. So now we know our acceleration. Now we take our acceleration and we just plug it right back into there. We multiply it by 5, and that will tell us our force of tension. So 5 times 6.17 gives us an answer of 30.85 newtons. And that is the force of tension in our string. Last type of problem you might encounter is another pulley problem. We have two masses, mass 1, mass 2. We have a frictionless pulley and massless string. Again, just so, and the pulley's massless just to make sure that we don't have any problems. And the mass of this one is 5 kilograms and the mass of 2 is 7.8. If we release these two, mass 1 is going to go up, mass 2 is going to go down, right? It's going to go in this direction, okay? So knowing that, I draw free body diagrams. Mass 1 has two things on it. It has the force of gravity and it has a tension force. Now since mass 1 is going to go upward, the tension force is positive, and I'm going to say the force of gravity is negative. Okay? So now the force of gravity, mass times g, our mass is 5, g is 9.8. So the force of gravity is 49 newtons. And I know my net force is going to be the force of tension minus the force of gravity. And that's going to equal the mass of 1, 5, times a. So Ft minus 49 equals 5a. Now for mass 2, my free body diagram, same thing, force of gravity and force of tension. Now, since this block, as we said, is moving downward, gravity is going to be positive and tension is going to be negative. So my net force is going to be force of gravity minus force of tension equals ma. Force of gravity is 7.8 times 8.9. And if I do that math correctly, I should get 76.44 newtons. So 76.44 newtons minus Ft equals our mass of 7.8 times A. Two equations, two unknowns. We can substitute. I'm going to show you another method here. I'm just going to add the two equations to each other. So I'm going to say plus Ft minus 49 equals positive 5A. And when I add my two equations, FT's cancel, and I get 76.44 minus 49, which is 27.41, and that's equal to 12.8A. I divide both sides by 12.8, and I get an acceleration of 2.14 meters per second squared. So that's my acceleration. I substitute it into here, so add 49 to each side, and I get the force of tension to be 59.71 newtons. I could also substitute it into this equation, right? I could take the 2 point and put it into here, and then subtract 76.44, and I would get 59.71 newtons. So that's the tension in the string and the acceleration. Again, two equations, two unknowns. You could have solved this in terms of Ft, right? Add 49, substitute it into this one, and you still could have got A. You still could have got your answer for A. That is just another way to solve, and you probably should have learned that from algebra class. Again, more two-body problems. I'm sure there's going to be some you encounter that we haven't seen before. Just remember, make two free body diagrams, write an equation, and then see what you can do with it. Again, if you have any questions over these things, let me know.